Rigel's 7000 series provides the capability to extend one-channel sampling to 10 gigasamples per second, the fastest of any mid-range scope. This flexibility makes it possible to identify and analyze high-speed signals with finer detail than any other instrument in its class, with 20x oversampling at 500 MHz. 7000 series also provides up to 500 million points of memory depth. This graphic shows the extent of these capabilities in one-channel mode. With the deep memory options, the 7000 is capable of 20x oversampling on a 500 MHz signal for a full 50 milliseconds. For longer time captures, 7000 can capture 5x oversampling on a 500 MHz signal for up to 200 milliseconds. Across all time settings, the combination of deep memory and high sampling in the 7000 gives you more flexibility in observing and analyzing high-speed signal anomalies. Let's take a look at an example how we use 10 gigasamples per second to analyze more signal characteristics. Here we see a signal with occasional glitches at about every millisecond. We're capturing this with the 7000 at 10 gigasamples per second, but we're out at 1 millisecond per division. We can see these aberrant pulses that are occurring. Let's zoom in and see what we can do to analyze these pulses further. Because of the deep memory, up to 500 million points in this mode, we can zoom all the way in to down to single-digit nanoseconds. So here at 2 nanoseconds per division, we get a clear image of what this pulse that's causing us some error in our embedded signal actually is. And now we can go in and measure it further. So let's add a frequency measurement. And let's go ahead and set that up to be around a cursor set. So now, even though we're capturing a pulse that happens every millisecond, and we can see it out at a millisecond per division with multiple pulses on the display, with that same data set in real time, we can zoom in and look at what is in reality a 1.5 gigahertz pulse. So this is a great ability to look beyond the 500 megahertz bandwidth of a scope and be able to capture and debug signals that are getting coupled in or correlated in with your data, and be able to analyze them. And because you can see their frequency, you can see their duration, and you can see them in the context of a larger signal, you can really find root cause and solve your problems faster.